Yes, hello everyone. So now we are going to discuss a question that comes under river crossing problem. Okay, so that's also a relative velocity concept. So let's look at the question first. Please look at the question. It says the current velocity of a river grows in proportion to the distance from its bank and reaches the maximum value V naught in the middle. Near the banks, the velocity is zero. Okay, a boat is moving along the river in such a manner that it is always perpendicular to the current, and the speed of the boat in still water is given as u. Okay, find the distance through which the boat crosses the river. Um, through which the boat crossing the river will be carried away by the current if the width of the river is L. Also determine the trajectory of the boat. Okay, so as per the question, we are having a river, right? So let me draw this. You have a river which, let's say, looks like this. The width of the river is given in the question as L. Okay, the speed of the boat. Now how the boatman is propelling the boat means he is trying to move his boat in upward direction, like vertically or perpendicular to the flow of the river. And what direction is the flow of the river? Like this is the direction of the flow of the river. Okay, so this is u. So can I say velocity of the boat with respect to river is equals to u j cap? Yeah, in that direction. But the river is also moving with what speed? Now this is a tricky part here. Generally, speed of the river is always given as a constant value, but in this question it is more realistic. They are saying that speed of the river near to the shore is zero, the close to the shore, but as you move towards the center of the river, the speed is actually increasing. And at the center, exactly at the center, you are having the highest speed. So to show this graphically, we can use a graph like this, and we can say at the center I am having the maximum speed of how much? V naught. And at the end near the banks, the velocity is zero. So can I say that this is how the speed is changing? Because I said it is linearly, proportionally it is changing, right? So I can say at the ends, at the banks, it is zero, and as I move towards the center of my river, my speed is increasing. Exactly at the center, that is at a distance of how much? L by 2 from the bank, my speed becomes maximum, and again after that my speed starts reducing and then again becomes zero. So can I create a quantity called the velocity gradient here, right? So I can say that velocity gradient, let me call it as what? Let me write it as, let's say, or a k, but k would be again confusing. I, j, k will come. So let's call it as c. Okay, this is the velocity gradient, and velocity gradient is nothing but v naught minus 0. I am considering between these 2 points. V naught minus 0, change in velocity, divided by in how much distance that is happening, L by 2. So that becomes 2 V naught by L. This is the change in velocity per unit distance as I go this side. So from 0 distance to L by 2, my speed is increasing with this rate. From L by 2 to L, my same speed V is decreasing at this rate. Okay, so if I am having speed of the boat with respect to river, and if I want now speed of the boat with respect to ground, because finally they are interested in finding the drift, right? The boat is going to drift. Why it is drifting? Because of the flow of this river like this. Instead of the boat going straight, the boat might actually go in this way, and because of that finally I'll be experiencing a drift, right? So the boat's final velocity will become in this way. Okay, so what is this velocity? This is the speed or velocity of the boat with respect to ground. I want that. So for that I can use the relative velocity formula. Velocity of boat with respect to river is nothing but boat with respect to ground minus river with respect to ground. I want this value. So can I write it as VBG is equals to VBR plus VRG. Now VBR is very simple, uj, a constant value. But VRG, river velocity with respect to ground, is not that simple. So what can I do here is I can try to create one equation for velocity of the river. Okay, so can I say like this, two parts. Let us think in this way. Velocity of the river can be written as c times y. What is y? Y is the distance along the river like this. So I'll call this as my axis, like this, y axis and x axis, with origin at this point. Okay, this is my origin. So v is equal to c into y, that is the speed of the river with respect to ground. C is nothing but 2v0 by L into y. Think about this, what I have written here. It's nothing but, the concept is simple, like we can say, like 10 chocolates is equal to this much rupees, so one chocolate would be how much, or one chocolate is equal to this much, so 10 chocolate how much. So that same calculation we are doing here. At the center, my speed is v0, and they said that the speed is increasing in a linear fashion. That means at any location, if I want to find out the speed, I can use a simple concept saying that speed at that location, which location? Location y is nothing but c into y, where c is the rate of change of speed with respect to distance, right? So I got this, but this is valid up to what value? This equation is valid if my y is lesser than or equal to L by 2, because if it becomes more than L by 2, then if I substitute more than L by 2, it will look like that my speed is still increasing, but you can see that the speed is actually decreasing after L by 2. So I have to create one more equation. What would that equation be? Velocity of the river with respect to ground equals to, this time my value should become v0 minus, decreasing, no, after v0 it is decreasing, so v0 minus c into y, like that. Okay, and this y should be what? It should be the distance from here. Let's say I'm talking about I need speed here, for example. So I will be writing it as v0 minus c into y. What is this y? Y is the distance from here to there. So I should not call it as y, because according to me this is origin. So y is actually the total distance. This is y. I am interested in then what? Only this distance, right? From the center, how much it has gone. So can I call it as y minus L by 2? That is this distance. So y minus L by 2. So this will be my formula for velocity of river with respect to ground, when, under what condition? When my y is greater than or equal to L by 2, like that. Okay, so two cases I am having for the velocity. Anyway, let us first find out the drift. Drift is kind of easier. We can say that which component of velocity is responsible for drift. So to obtain that, we can write this equation first of all. Okay, see, velocity of the river is continuously changing, but one thing is sure, that velocity of river is always along which direction? X. And the velocity of boat with respect to river is actually along the y direction. So in simple way, I can write velocity of boat with respect to ground, that vector is nothing but boat with respect to river is u j cap plus the river velocity. We don't know, two equations I have, so I cannot substitute anything. I can just say vrg I cap. And I am interested in drift. See, drift is something that happens along the x-axis. This is what we call as drift. How much the boat drifted away from its actual direction. So that can be calculated by which component? The x component. So I will use this to find out the drift. And for finding drift now, I have to do it in this way. I will say from here to here, that is from 0 distance of y to L by 2 distance of y, how much drift has happened, I can calculate. Once I get that drift, if I multiply that by 2, I'll get the total drift, right? Because how much drift happens from here to here, same amount of drift should happen from the middle to the other part, because it's symmetric. So from there we can understand, right? Now drift can be written as what? Drift, it's a distance. So you can say distance is nothing but speed into time. I can say that. Which speed? speed along the x-axis. So Vx into time I can do. But the problem here is that my drift is, the speed is not remaining constant. It's varying with distance, with the x. So I'll have to find out drift at each and every section and I'll have to integrate that. Okay, so that's what we are going to do. Let us say I am at a distance of y from this end. I'll draw this diagram once again. So this is my diagram. Now I am at a distance of y from this end. At this point, how much is the velocity that I am having? I can say that the velocity is equal to, what is the condition of my y? I'm assuming that y is lesser than L by 2. That is my condition. Then what is the velocity that I have for the river? The velocity of the river with respect to ground would be nothing but this formula. I can write 2 V0 by L times y. This is the velocity that I have at that place, at here. Okay. So then how much distance, how much drift will I get in this direction? Let us say dx for a small amount of time, dt. So that small drift I can find as dx is equal to, using this formula, the small drift dx is equals to the speed at that position rg into the small time interval dt. Now I can write this as finally again what? Dx is equals to Vrg is nothing but 2 V0 by L into y dt. Okay, now what are the variables here? You check. Okay, dx, change in x. Okay, y is a variable and dt is a variable. So now what I'll have to do is I'll have to find the total drift. Total drift is nothing but integration of dx. Okay, but here I am having a problem. I have y and dt as two terms. So what can I do for that to get a relationship? So can I use the the y-axis of my journey? Along the y-axis, what can you say about the speed? It's a constant speed, right? So with this constant speed, can I find out distance? What can I write for that? Dy by dt is equal to u. Okay, I am interested in finding drift at a location y. Okay, so to find the total drift, I'll have to integrate. Integration of dx is equals to 2 V0 by L integration of y dt. Okay, now y dt, y is the distance and dt is the time. What can we do? This speed in vertical direction can be written as u is equals to the vertical distance covered by time, which is a constant actually. Okay. So can I write it as dy by dt equals to u? Okay. So instead of dt, can I substitute it as dy by u? Right? For a moment I got stuck there, but now I am able to substitute. So now I'll be able to integrate that. See, so now I can substitute it and I can say this integration of dx, what's the limit of my dx going? It will go from starting from 0. Initially the drift, dx is nothing but the drift that has happened. Initially the drift was 0 and then finally I'll be getting the total drift. So I can say it's going from 0 to total drift. I'm calling this drift as capital D, let's say. Okay, so I'll get this value as d equals to 2 V0 by L. So instead of y and dt I can substitute as dy by u, right? And I can take that u outside. So my u will be coming outside because u is a constant. Okay, Now integration of what I have is y dy. What's the limit of my integration? Y will be starting from what value? 0 until, remember I am only integrating up till what value? Up till L by 2. Okay, so we are talking about this until L by 2. So 0 to L by 2. That's my limit. Okay, so with this I'll be able to obtain 2 V naught by UL. This integration would give me y square by 2 limit going from 0 to L by 2. So the moment I substitute the limit, I'll be getting it as d is equals to 2 V naught by UL, and the limit that I'll be having is this L square by 4, and this will become 8. So my answer would be d is equals to V naught L by 4u. Now there is one problem. What's that problem? I showed you something as the total drift. The total drift is d, but I am integrating from where to where only. As I said in my entire discussion, I had two types of velocities possible. So while finding the drift, I said that whatever drift is happening from here to the center, same would be happening there. So if I am only integrating from 0 to L by 2, so the drift that I am getting is not actually d. What's the drift that I am getting? It is d by 2, right? It should be d by 2. So this value is actually d by 2 that I am getting, because I only went for half journey. Remaining half I said would be exactly same, so I'll double like that. So the drift that I am getting is only half drift. So if I'm interested in the total drift, that will be d is equals to V naught L by 2u. This will be the total drift. Okay. So this is about finding the drift that has happened to the boat. Now they are also asking us to find out the trajectory. I'll take that up in the next video, because now I'm not having the space. Next video will continue from here. I hope you have understood. Once again I'll say, generally in all questions what they do is they'll say that the velocity of the river is constant. If velocity of river is constant, then this VRG will become constant. Our life would have been easier. But here they have not made it constant. They are saying the velocity is varying linearly along the width of the river, and in such a way that at the center it is maximum, both ends it is 0. So I'll have to form two separate equations for the velocity. The first equation talks about the increase in the velocity happening until the center. The second equation talks about the decrease in velocity happening from the center to the spine. So if you put this value of y as L, what would you get the answer? See for yourself, because C is what actually? C is 2 V naught by L. The moment you put this value as L, you'll get here as L by 2. That L by 2 and here this L by 2 will cancel. Finally the answer V naught minus V naught will become 0. Right? So this equation gives for the part from the center to there, and this equation gives from this end to the center. Anyway, so that's about the velocity equation. This is the fundamental part of this question. First you have to form this equation. Now to find drift, it is easy. Because of the symmetry, first half journey speed is increasing, next half of the journey the drift speed is decreasing, right? The river speed is decreasing. So it's very obvious that if I find a drift up till the center, same drift will be offered by the river in the top also. So total drift happening is 2 times of this value. So I can say if total drift is d, I'm calling it, then this much drift should be d by 2. So to find that d by 2, we were doing this step. What is this step? I showed you in the diagram. I went at a random location in the river. What location from the bank at a distance of y? What is the velocity at that location? I can use this formula. This is the velocity. So this is the velocity at that location. So what is the drift happening there? This velocity in this direction, I can say for a small duration of time at this moment here, the drift happening would be dx is equals to speed into time. I'm using the formula speed equal to distance into time. Now speed value I substituted, okay, distance value dx, if I keep adding that distance, I'll be getting the drift, right, total drift, and this dt value as it is. So now when I'm integrating, I'm finding a problem with this y dt. So here again a problem, right? So to rectify this problem, what I did is I tried to use that vertical component, the y component of my motion. This was the y component of the motion. So I tried to analyze dy by dt is nothing but u. So from here I am getting dt is equals to dy by u. I substituted that. Now I am able to integrate. I got the total drift as v naught L by 2u. I hope you have understood this. Okay. So I'll stop this video here. Thank you.